So my name is Alexandre Cassaigneau. I'm a rotating equipment engineer working for TotalEnergies, and we're here to present you with, together with Matias, our remote monitoring initiative that now is nearly 10 years old within our organization. So just to start, a few words on TotalEnergies. So we are an integrated multi-energy company with 100,000 people around 130 countries in the world. We are a historical oil and gas company, switching from oil and gas to a multi-energy company. So we have a slide video to show you.
Energy is life. We all need it, and it's a source of progress. So today, to contribute to the sustainable development of the planet facing the climate challenge, we are moving forward, together, towards new energies. Energy is reinventing itself, and this energy journey is ours. Our ambition is to be a world-class player in the energy transition. That is why Total is transforming and becoming TotalEnergies.
So just a quick overview of TotalEnergies perimeter. So as you can see, we are integrated. So we are producers, transformers, and distributors of energies. To be frankly speaking, we are more in the red part currently, or the dark blue part, so oil and gas, LNG, but we are switching currently to a more lighter blue, and who knows, in the next future will be greener and greener. The idea and the ambition is to become carbon neutral by 2050, and with a milestone in 2030 to reduce by 40% of our carbon footprint impact. And to support this transition, we need to focus on our strengths today, our operational excellence. And that's why we are talking here about our initiative in the upstream part of TotalEnergies. So our remote monitoring center is called Remote Assistance Intervention and Diagnostics, so-called RAID, and where it's come from. It's coming from the early 2010s, where we had a lot of projects coming online, mainly in West Africa. We had a growing fleet, and we had to face an increased number of failures across our fleets. And last, in 2009, we had a major accident offshore with severe consequence. A turbo compressor got fired. And we had to shut down hopefully no injuries and no fatalities, but we had to shut down the platform for 6 months. So I guess you understand the consequences. So we went through all these failures, and we figured out mainly that half of those could have been anticipated if we had a good condition-based maintenance and a proper remote monitoring follow-up. Basically, 80% of our centrifugal compressor failures could have been avoided, and 30% of our gas turbine failures. And I'm giving the hand to Matias, our SME in this subject.
Good afternoon. Are you okay? Thank you for still being here right now. Do you know the difference between a smart man and a wise man or woman? Smart man fix the problem that the wise man has avoided. We are trying to get into this direction. We are in the monitoring center using the smart signal software to anticipate our failure, trying to get wiser and wiser. We are here to talk about data. What is data for us? At least data for me, who is a mechanical engineering with a maintenance career, starting on the oil and gas plant, is the data directly coming from the machines. it's a real data. Pressures, temperatures, flows, vibrations. Those data comes from our production plants through their sensors, through the industrial networks, and is analyzed with Smart Signal. And Smart Signal is a software which you should already know, I hope for you. At least those kind of analytics in order to detect and to predict or anticipate the failure. This data comes through the internet to our remote monitoring center located in southern France, in Pau. I invite you to come and visit us if you have the opportunity, at least to visit France, especially during the fall. This data is analyzed with our colleagues in this center. So we are 4 analysts in this center to monitor the data from all our fleet, roughly 800 equipment. And after the analysis of this data, we communicate to our sites, generally the production plants, in order to implement or to perform the corrective action before the problem occurs. The way we do that, and we choose to do that, so about a decade ago, is to centralize the monitoring. Some of you know that either we externalize the monitoring or we keep this monitoring in-house. And this is the strategy we decided to employ within TotalEnergies, is keep this monitoring in-house in order to analyze the entire process, to correlate similar issues around our fleet, because we are using different manufacturers, different operating conditions, and as well strengthen the communication between headquarters and our affiliates. Communication is a very important issue. One of our colleagues previously said that. He's true. And capitalize the internal competencies so that all those competencies remains in our company. We are able as well to analyze and change or make our maintenance philosophy evolve from the condition-based maintenance to the planned maintenance, preventive, predictive, whatever you want. But at least we use the data and the history we have on our machines in order to adapt the machine and the site operation to the best maintenance philosophy. And of course, because we all do this in the business, we reduce the flaring, we reduce our impact environmentally. That is to say, we maximize and we optimize the oil production. I can say that because we are here between industrials, but technically we prefer to say that we reduce the flaring and we optimize the operation. But you know, the world needs oil and energy, and we are here to do this and to answer the demand. So TotalEnergies upstream, meaning the production of the crude oil to the refineries, we are monitoring assets since 2013. At that time, Smart Signal was not yet acquired by General Electric Digital. And we monitor equipment around 11 affiliates, 11 countries, let's say, 360 shaft lines, roughly 300, it gives roughly through the Smart Signal, roughly 36,000 alerts a year. That's all of the alerts that we monitor in our remote monitoring center. We analyze them and we, let's say, sort the real alerts through all the false positive or real positive that we have. And it gives us roughly 500 catch, meaning real potential issues that we have avoided throughout the year, throughout our 11 affiliates. In order the presentation to be a little bit more technical so that you don't fall asleep too early, I will, let's say, give you a few of real cases that we have raised, let's say, a few years ago. But before that, keep in mind that our failures generally occurs on the equipment, generally mechanical issues, bearing problem, for example, dry gas seal issues, or instrumentation failures. Roughly half of our failures come from instrument failures. So maybe we have an action to take related to our instrument provider. However, the instrumentation is very, very important for us, because if we don't have this instrumentation, we don't have the data. And without the data, in France, we are blind. So an example of key catch that I would like you to understand so that you, let's say, can feel how important the remote monitoring is for our industry. And I have selected a few examples that doesn't necessarily require a high level of technicity or to be very, let's say, competent in the machine so that everybody can potentially understand what we are talking about. Compared to our colleagues previously who used the Honeywell software, we use Smart Signal, and finally, the trends, it's just a matter of colors, but the philosophy is roughly the same. For us, the blue line is the real-time value, the one which is actually drifting. And the green line, which is the most important in the remote monitoring, is the anticipated value. So this is the value which is calculated, processed by Smart Signal, so that we can compare the real-time value with the historical value. Because as he said, and he's totally right, without this value, we cannot, let's say, we cannot see directly if there is a problem or not. In this one, we saw a deviation on the blue line. This is a vibration of a compressor. This compressor produces 50% of a site which produces 100,000 barrels of oil equivalent per day. So you know the price of the oil today. You make your own calculation because I cannot. But we all know that the figure is quite important, especially after 6 months of shutdown. And it led to 10 days of unavailability. With anticipation of this failure, we could reduce this downtime to 3 days. And it makes us save a consequent amount of money. With a very simple analysis of the trend, the vibration increase, we anticipate the shutdown of the machine before the bearing fails. We replace the compressor. It's very quickly done. It's very simple. And we save a lot of money on that one. We save a lot of money because we save a lot of time. And there is a direct link between the two in the oil and gas. This one is another example. This is an axial compressor of a gas turbine. So GE Digital is our partner for at least a decade, but GE Aero, provider of this turbine, it's another story. This one is very interesting. You see, I'm sorry that I cannot directly show you, but you understand what I mean. The blue line and raise an alarm, but the level of vibration is widely below the, let's say, the actual shutdown limit on the site, meaning that whatever the technical personnel on shore, whatever the round, let's say, the operation, we cannot see that something is happening on the machine, but we can. We know that the turbine is typically, let's say, facing some issues on the blades. We recommend an inspection of this turbine so that they can plan the shutdown of the machine, inform the customer, in this present case, that the production of gas will be reduced. We inspect the machine, we confirm there is a technical issue on the machine, and then we can plan the replacement. So on this picture, you can see 2 periods of shutdown, one for inspection, one for replacement of the engine. And afterward, on the right side of the picture, the machine restarts with normal operating parameters. At least this is a very good example of anticipation of a failure. If the failure is not anticipated, we don't have the material on board, we have problem of customs, it will take months, probably or eventually problems of weather, it can escalate and we don't know where is the limit. So this is real issues that we are facing, let's say not every day, but with a significant frequency. And one last, this one is interesting as well because it's very obvious to understand. When there is no green, it means that the machine is stopped. So the machine on the left side is running normally. There is a spike, the machine is stopped, and when the restart, the blue line, I remind, is the actual value, is much more higher than usual. We, let's say, analyze all the data with all the correlated parameters. We understand it's coming from a ventilation issue on the machine, which was the gas turbine. So considering our experience around the fleet, we know it's generally a problem of damper. So we recommend our operators to go and check the dampers, see if the ventilation is okay. That's what they do. They close the damper and the temperature comes back to normal. So this is typical example and real example of the relation between the headquarters. When we are working, we analyze the data from, let's say, thousands of miles away from our operation. And with a good communication with our sites, we can perform this kind of anticipation and avoid problem. So that's why we are trying to get wiser and anticipate our failure before they happen. Otherwise, as we are smart, we know how to fix them. But the better if we can avoid. So thank you for being here and listening to me.